Assalamualaikum and hi. I'm Ashita binti Manijit. We present on the topic strength assessment of marine stabilized soil using artificial neural network for road construction. These are the contents of presentation today. Introduction, prediction shear strength, materials and methods, results and discussion, and lastly is the conclusion. Introduction. As you can see here, the stabilized soils is a process where the original marine soil is added with an additive to increase the strength properties of the soil. For this case, the additive of stabilizations are Caucasia powder and lime powder. In this study, marine soil was obtained from the area of coastal, and then the soft soil is due to its lower strength and high compressibility. The shear strength parameters are obtained by considering the Moore column failure criterion, so the existence of soil failure on any plane when resolved shear stress reach the critical stage. In these conditions, the additives are used to improve the soil properties by using the Caucasia powder and lime powder. And the shear strength predictions was used by artificial neural network consists of input from plasticity limit, liquid limit, and plasticity index. It is very useful to predict the shear strength parameter by using the ANN method. Prediction shear strength. The shear strength of soils can be assessed by performing artificial neural network in prediction the strength parameters. The prediction models of material properties such as plasticity limit, liquid limit, and plasticity index are useful for prediction shear strength parameters in bearing capacity, slope stability, and earth pressure problems. Artificial neural networks are a form of artificial intelligence to simulate the behavior of the human brain and nervous system. In this neural network, the data will be stored in layers starting from input and followed by output and several hidden layers. The ANN has the ability to relate the input data and the corresponding output data, which can be defined depending on the single or multiple parameters employed to solve the linear or nonlinear problems. Materials and method. In this study, the testing for materials was marine soil and by using the additive from Caucasia powder and lime powder. In order to determine the properties of the soil, there were two methods involved. First was experiments, and then the second one was artificial neural network to predict the strength of the soil. The experiments were involved for determine the index properties and also the engineering properties of the soil. And then the answers will be used as input in the ANN. Results and discussions. As you can see here on the left side, this is the results. The Caucasia powder has a lower value of axial stress compared to the control sample, but after lime powder is added together in the soil, the result increased rapidly. The unconfined compressive strength of the marine soil infused with Caucasia powder is lesser than the control sample. The bar chart shows the value of unconfined compressive strength of the control sample, which is 96.5 kPa. This value is higher than those of the stabilized soil, which is 78.5 kPa. This shows a sign that the reaction to form a cemented compound within the soils are not created properly. The results obtained that the lime powder has again proved itself as one of the most effective stabilizing agents for treating soil where the value of unconfined compression strength of the marine soil has increased twice the value of the control sample. The values of stabilizer and plasticity index of various soils from previous and current studies is shown on the left side here. It shows varied reading of unconfined compression strength for various types of stabilizers and soils used in the testing on A and N. Meanwhile, on the right side here shows the A and N result, the regression plot for unconfined compression strength in the testing phase. The value of coefficients of determination R squared were nearly 1, which is 0.98. The A and N able to model the strength parameters of stabilized marine soil with reasonable accuracy, and the model can generalize the training data to simulate new data tests. Conclusion. For UCT, the addition of cookie-shell powder has reduced the compressive strength of the marine soil. By adding the lime powder as a secondary additive, and the result shows that the compressive strength of the soil has slightly increased. The California bearing ratio shows that adding 20% of cookie-shell powder has given a result which is also lower than the control sample. Lime powder of 20% is added as the secondary additive, and the result shows that the CBR value is higher than the control sample. The correlation coefficient R squared equal to 0.98 was obtained from the A and N model, which indicate that the model can rationalize the variations between the predicted and target values. That's all. Thank you.